Hi, good morning. Blanche Hardy, Lake County hydrogeologist. We're at the point we're talking about potential impacts. So well construction is unpredictable. In karst geology, which we have in Sumter County and we have in Lake County, so if you look at the pink picture to your left on the slide, you can see that these are substantive sinkholes, enough to be mapped by the state in the direct vicinity of the well, which is the red star. And that pink color indicates that the state has found this area indicative of karst geology. Damage to aquifer springs and seeps. The center map shows you that there are springs, and again, in the immediate vicinity, the left part of the map is Sumter County, the right part of the map is Lake County. So we have class 1 to class 4 springs in this area already. And then on the right-hand side, there are 729 potable wells within 1/2 mile of this site. So these are cross-sections. You'll see a small map inserted on each cross-section that shows a line. These wells, exploratory wells, were drilled by the U.S. Geological Survey. These two maps appear in the definitive report that they issued on the Florida and Aquifer in Central Florida. So the red box indicates where the screened interval or open interval of the proposed phase 1 injection or a class 1 injection well would be. This first map is the map that was provided by the consultant to Sumter County. It has been the map that's in the publications. As you can see, that white area is called a confining layer, but it is actually defined as a confining or semi-confining layer. It consists of a carbonate called an anhydrite. Anhydrites react with water. They also are slightly caustic. Leachate is very caustic, so one can anticipate there will be some reaction with that formation, but it is in a confining layer. What was not included in the PowerPoint that was provided is the cross-section to the right. This cross-section, and let me step back a second, in the maps that show where the lines that the USGS wells were installed, I want to point out this is 7 or 8 wells for the state of Florida. So this is not well defined by any stretch of the imagination from a geologic standpoint. So this first one is a well that's kind of by the site, slightly to the west. The second one is by the well, again, kind of by the site, slightly to the north. These two drawings were in the publication, as I mentioned. The well in the second drawing, the location of the proposed well in the second drawing, as you can see, is in blue. That is a lower aquifer. The red line, the red dotted line that goes through both of these drawings is the saline interface. So in that first drawing, this well is directly below the potable water supply that has been identified as an alternative supply should we need to go deeper than we currently do to address the growing population of the state of Florida. You see the red line is slightly above that anhydrite in the second drawing, but again, we're right below a future potable water supply that other counties right now and public water suppliers are looking at as alternative supply. When you're in a bubble, which we'll talk about in a minute, you're in the freshwater bubble, you're 2,600 feet of fresh water. So that first one that shows that red dotted line, that's fresh water above there. That's your drinking water. That's your future drinking water. The lower water, that's your drinking water 20 or 30 or 40 years from now, because those lower supplies are called juvenile water. They're not rechargeable. At 2,000 feet, you don't get recharge in the same kind of way that we get Florida and recharge right now, where the superficial aquifer and our sinkholes accept water, it percolates down through the karst system or through the sand into the limestone. These are thousands of feet deep. This is water that was deposited when it was deposited millions of years ago. So these are not infinite supplies. These are finite supplies, but it's our future. So moving to the next drawing. This drawing is called a plate. Every single one of those dots, and I put the map there showing the grid of dots. Again, these are very few dots to define the subsurface geology of Florida. at the depth that we're talking about, this plate, you have to go to the USGS and you have to acquire this plate. It's publicly accessible, but certainly a consultant, and definitely I know that these plates exist, and immediately when I saw the PowerPoint, I went and got this plate. If you look at the star on the map, this well that I have put the red box around is in immediately direct vicinity of this proposed well. And this one shows that, again, this will be in that potential 20, 40, 50-year water supply that we may need to secure and treat, and I call it mineralized, but we'll call it salt water, in order to provide for our growing population. So a few more maps. If you look in the middle, the blue area and the pink area that doesn't have dots in it, this is your good water. And that's you. This is Lake County and Sumter County. Lake Sumter and Marion County are the water supply for millions upon millions of citizens between Tampa and Cocoa Beach. The Green Swamp is the water supply for Central Florida. And this is where we're talking about allowing or not protesting this proposed well. And then the next one I think is the best map to look at. That purple is 2,600 feet of fresh water. This well will sit right below that. So we talked about there's over close to 200 Class 1 injection wells. Well, here's where they are. There are 4 injection wells in the spine of the state. All of the injection wells, almost all of the injection wells, the Class 1 injection wells, are on the coast. So those injection wells have an open borehole or a screened interval that is under 1,000 feet of salt water, not under thousands of feet of fresh water. It's under thousands of feet of salt water. So you don't see a lot in the middle of the state, because when you put them in the middle of the state, you start to potentially impact water supply. So I know that the discussion has been, well, these wells have never contaminated a drinking water well. Well, you're not allowed to put them by drinking water wells, so that's excellent news. I'm glad to hear that. However, that does not mean that the injection wells, in all classes, I'll go over all classes, have not contaminated groundwater. And I think most people know about Piney Point. Piney Point is the gypsum stack outside of Tampa that discharged 6,000 gallons of untreated industrial waste into Tampa Bay. The well didn't fail, the pump for the well failed. So you can't just look at the well and say, oh, these wells are great. You have to look at the system. The pump failed, and by the time they shut it down, 6,000 gallons of water had been discharged into the surface water. There's another one in my list here where I talked about the anhydrite. They had a failure into the Biscayne aquifer, where the well reacted. The material they were injected included acidic wastes, and it rejected with the anhydrite, and it tore open the well. It left a great big gap in the well, so it not only contaminated the groundwater, deep groundwater, it contaminated groundwater above the deep groundwater. So there are a number of instances in Florida, and a lot more instances outside of Florida, where deep injection wells have contaminated groundwater. So unfortunately, in this state, if you put one in Sumter County, it's not going to just contaminate groundwater. If there's an accident, it's going to contaminate the drinking water supply, my drinking water supply, your drinking water supply. So I'm happy to answer any questions. I'm happy to share any of the information I have about other failures in the state of Florida. My recommendation as your hydrogeologist is that this is a very bad idea. And earlier, we heard that there are other ways to treat leachate. So this isn't an emergency. This isn't, we have a crisis, we have no other choices. There are other choices. It's expensive. This is probably not quite as expensive. A couple things. There's nothing so far I've heard that guarantees they won't accept leachate from outside of Sumter County. Now, our solid waste does go to this landfill, from my understanding, and you can correct me if I'm wrong. I also asked, well, what is the reduction in the tipping fee to the citizens of Lake County if this is allowed? What's our savings? Well, nobody's talking about a reduction in tipping fees for being able to put leachate in potentially in a manner that could impact our groundwater supply. So just 2 points to think about. Thank you.